Hi guys. So, true story, this is my second time making this video because I made the whole thing and then right when I pressed the done button, my computer crashed. So my computer's not doing very well right now, so I'm not going to write on the screen. Instead, I'm just going to show you the work that I wrote out. So hopefully this time my video will work. Okay, so this first question asked you about continuity. And so continuous, hopefully you're thinking to yourself, three things: the limit from the left equals the limit from the right, which equals the function value at that point. Here our piecewise function changes definition at 5, so that's where we need to make sure that we have continuity. So you would set the limit from the left equal to the limit from the right equal to f of 5, but f of 5 is the same thing as the limit from the left in this case, and you should find the value of b. We've done so many relative maxes and relative mins. Hopefully you got that one. Number 3 is a tricky one. And this is one where I really would look at the multiple choice answers to help you figure out what you should do. You'll see that it says that it's in the shape of a rectangle, so it's 5 by 3. I always like to draw it out just to know what I'm looking at. And then we have this density that's in trees per square mile, so I always take note of units. You know that which expression gives the number of trees. So how do we get from a rate to an amount? We take the antiderivative. So we should just be taking an antiderivative of the density function. So that automatically eliminates d and e, right? Because there would be no reason to take the derivative. We simply want to go from a rate to an amount, so all we do is take an antiderivative. Now, this is 3 by 5, right? So if we add up, all of these are adding up from 0 to 3. So if we're adding up all these slices from 0 to 3, we should be multiplying it by the height, which is 5. So our answer would be C. So that's just how I do that problem. And what else do I want to go over? And this one right here, we're going from H and we want to get a drawing of the derivative. We know that it is decreasing, increasing, decreasing. So its derivative would be negative, positive, negative. So which one's negative, positive, negative? Only B is negative, positive, negative. So that's definitely my answer there. On number 7, don't forget that it is a chain rule, and to remember that, I would rewrite this first. So I have 4 sine x plus 2 to the 1/2 power, so it's clearly a chain rule type thing. So if I have box to the 1/2, I have 1/2 box to the negative 1/2, and then the derivative of what's inside the box, the derivative of 4 sine x plus 2 is just 4 cosine x. Now, I do not have a calculator, so you need to make sure that you're able to do simple things like figuring out the sine of 0 and the cosine of 0. So we know here we have the 0.10, so the cosine of 0 is 1 and the sine of 0 is 0. Just make sure that you got some trig stuff down, please. Now, number 9, they want us to find the equation of the line tangent to the curve. Remember, whenever you see line tangent, you should be thinking to yourself, I need a slope, I need a point. Well, they already give you the point. We got the point, and then you need to find the slope. And to find the slope, you need implicit differentiation here. Remember, every y has a baby inside of it. So the derivative of x squared is 2x plus the derivative of y squared is 2y times y prime. And then don't forget that the derivative of a constant is just 0. So the two things that people mess up in this one is they forget that every y has a baby inside of it. So they forget this y prime, and they forget that the derivative of 169 is just 0. So once you do that, I would just plug in the point immediately right there, solve for dy dx, and then you have a point, you have a slope. You can come up with the equation of the line, and then you just have to get it in standard form for this problem here. In number 10, they asked you where's the speed the greatest. So speed, remember, is the absolute value of velocity. So it's going to be the greatest here at this point D, because we're saying which is the biggest number in absolute value. So this point D would be the biggest number that we see when we take the absolute value of it. Find the area of the shaded region. So that would just be, of course, you need to go from here to this point here. So we need to find this intersection point. So you set the two equations equal to each other. X squared plus 1 equals 5. We get x equals plus or minus 2, but clearly we're just going from 0 to 2 in this case. Then we would do top curve minus bottom curve. So it would be the integral from 0 to 2 of 5 minus x squared plus 1 in parentheses. Don't forget to distribute that negative sign, and then you would find that antiderivative and get the answer. Number 12 is simply a formula you need to memorize, and you need to start memorizing these formulas. So you need to know that the antiderivative of 1 over root 1 minus x squared dx is the arc sine or inverse sine formula. You just got to memorize that. So if you memorize that, this is a little variation of it, but if you knew this, you could automatically eliminate B and C and D, and you would be left with A and E. In this one, you would probably ask yourself, is this a U sub type thing? And it's probably not. Doesn't this look so similar to the formula, except this is the A squared, actually, if you look up the formula. That would immediately get your answer down to A if you could apply that logic. Or you could just go and make sure that you memorize that formula accurately. In number 13, I really want to make a point of this because it says that f has an inflection point at x equals -1. So we know an inflection point means that f double prime changes sign at x equals -1 because that's where the inflection point is. Now, you've heard me say a million times that f double prime equals 0 does not mean that we have an inflection point. I'm going to say it again. F double prime equals 0 does not mean we have an inflection point. It means we potentially do. But if we know there's an inflection point at -1, then we know f double prime has to be equal to 0. Why? Because in order to change sign, we've got to go through 0. So once again, if f double prime equals 0, it doesn't necessarily mean that you have an inflection point. But if we know we have an inflection point, then we know that f double prime equals 0 there, okay? So now that I know that f double prime equals 0 at x equals -1, I can just go ahead and do it. And I would rewrite my equation instead of k over x, I would rewrite it as kx to the -1. So I have then the derivative is 4x minus kx to the -2. Then take another derivative. I have 4 minus 1 times a minus 2 is plus 2 kx to the -3. At that point, I would plug in the -1. And then I know, again, that f double prime of -1 equals 0. So that's what I did. Right there, I set it equal to 0, and I got my answer, k equals 2. In number 14, this is a simple use up, a very simple use up. I have the sign of something, so I need to unchain there. U equals 3x plus 4, du equals 3 dx. So I just want to isolate that dx. I get 1/3 du. So I have the integral of sine u times 1/3 du, and then I just complete that problem. When is this concave downward? We know it's concave downward when y double prime is less than 0. So I'm going to rewrite this as 2 parenthesis 4 minus x to the -1 because I think it's easier to take the derivative that way than to apply a quotient rule. So then the first derivative is just -2 quantity 4 minus x to the -2, don't forget to chain, times -1. I simplified that to 2 times the quantity 4 minus x to the -2 power, and then take another derivative. I get -4 quantity 4 minus x to the -3. Don't forget this chain times -1. So I rewrite that as 4 over 4 minus x, the quantity cubed. Remember, to get the critical values, I set y double prime equal to 0, or where y double prime does not exist. Y double prime never equals 0 in this case, right? Because the numerator is never 0, but it does not exist at 4. So I put 4 on my number line here, and then I just see if it was 0, for instance, I would have a positive. So that would be positive. And then if I had a big number, I would have negative. And so concave downward, where is it negative? 4x is greater than 4. For this one, this is just a pain in the butt, honestly. Here's the position function. To get the acceleration, I need to take a derivative and take a derivative again, and I need to apply a quotient rule, and so I'm not going to do that one for you right now. Number 17, they give you this f of x curve is g of x plus 5, and they say find the area between f and g. Now, you know you have to do top curve minus bottom curve. If you know that f is g plus 5, obviously the f is on top. The f is actually 5 units on top of the g curve, isn't it? And so we're going to be doing top curve minus bottom curve, f minus g. What is f? F is g plus 5. So I have f, which is g plus 5, minus g. G plus 5 minus g is just 5. The antiderivative of 5 is just 5x. Evaluate that between a and b, and we would have 5 times b minus a. And that would be our answer there. Number 18 is just a reading question. Number 19, I'm going to skip. It is just a problem where you have to draw it. And because it says it's inscribed rectangles, the hardest part about this problem is just that you need to draw it very accurately, because since it's inscribed, it means it has to go underneath of the curve. And so sometimes underneath the curve is left endpoints, and sometimes it's right endpoints, and sometimes it's midpoints. Look at the answers for this one. Try your best on it. Do need to be able to so accurately draw this without using your calculator, and I think that's the hardest part of this question here. Again, inscribed just means it's underneath the curve, and so I'm not telling you do left, right, or midpoints. You just have to pick the one that is specifically underneath the curve. Number 20, this one I really, really like because I can eliminate so many answers right off the bat. You can see that across all the x values, nothing is changing, right? It's the same across all the x values. Where it changes is when y changes. So when the y changes, I see a change in the slope field. So that means that our differential equation is dependent only on y. So I can eliminate a, b, and c right off the bat. Then to figure out if it's d or e, I just plug in a value. So let's just pick a point. Let's say here at 0, 3. So at 0, 3, when x is 0, y is 3, it's definitely a negative slope, right? So x is 0, y is 3. So 1 plus 3 squared, that would be positive. So we need to eliminate d because it's definitely a negative slope. If I put it in here, 1 minus 3, that would be -2, a negative slope. Confirm e is our answer. On number 21, it says f prime is less than 0. So what do we know about f? That means f is, oops, I wrote increasing, should be decreasing. So change that, that should be decreasing. And f double prime is greater than 0. That means it is concave up. So which one is decreasing and concave up? Decreasing, concave up. So that answer there is D. Number 22, you need to know that this means to take the second derivative. So you better get that notation down. Take the second derivative. We need a product rule, x squared times y squared. Don't forget your product rule. derivative of the first times the second plus the first times the derivative of the second. The derivative of the second, the derivative of y squared is 2y, y prime. So what is that y prime? We know the y prime is x squared, y squared. So you would substitute that x squared, y squared in for the dy dx. How did I know I had to do that? Because this answer wasn't an answer choice. It was only in terms of x and y. So I put that in, I simplify it, and I'll get an answer. On number 23, this is a really cool one once you identify what you need to do. So what you need to notice is that this is a quotient rule, isn't it? Derivative of the first times the second minus the first times the derivative of the second all over the second squared, where the second is this f and the first is the g. And so this is just the derivative of g over f. That's what this is, the derivative of g over f. So I wrote g over f prime. So what we're trying to do is we're trying to find the antiderivative of g over f prime. Now how do you do that? You might get confused, and so I did this little aside just to show you what to do when you get confused. Go to something simple. We know the antiderivative of f prime would leave us with f. Evaluated between 2 and 8, we would do f of 8 minus f of 2. So bring that down to this example here. The antiderivative of g over f prime would just be g over f evaluated between 2 and 8. Again, what did I do? I did f of 8 minus f of 2. So I should do g of 8 over f of 8, put in the 8 first, minus g of 2 over f of 2. And then I would just plug in the values from the table and I would get my final answer. On 24, this is just a product rule. So the derivative of h would be the derivative of the first, f prime times g, plus the first times the derivative of the second, f times g prime, and then you put in a 3. What is f prime of 3? F prime of 3 means what's the slope of the f curve at 3. So the slope of the f curve at 3, that's just this line right here. And you can see, just pick 2 points on this curve. I go down 1 over 1, 2, 3. So the slope would be negative a third of the f curve at the point 3. So I have negative a third, and then g of 3 is just look at the g curve at 3. We're at a y value of 3, so that would be 3. And then f of 3, look at the f curve at 3, and that's 1. So we get 1. And then g prime of 3, look at the g curve at 3. Again, that's a linear slope, so this is really nice. We're going up 1 over 1. The slope is just 1, so that's the value 1. That's how you do that one. Number 25. So I started here. It says the circumference of a circle is increasing at a rate of 0.5. So I know dc dt is positive 0.5 because it's increasing. What is the rate of change of the area of the circle when the radius is 4 meters? So I know that dA dt is what I'm trying to find when r is 4. So area is pi r squared, and so dA dt would be 2 pi r. Remember, the r is changing over time, so I need a dr dt. But what is my dr dt? Well, I go back to the piece of information that I had. I had something about circumference. Circumference equals 2 pi r. So dc dt, what is it? Because they give it to me. It is 2 pi times dr dt, right? And so that way I can solve for dr dt. Again, I don't have a calculator on this one, so I like to think of 0.5 as 1/2, because then I do 1/2 divided by 2, that's 1/4. Then this pi goes on the bottom also because I'm dividing by pi. So 1 over 4 pi is my dr dt. So now I can go back to my dA dt equation. 2 pi, my r was 4, my dr dt was 1 over 4 pi. The 4 cancels out with the 4, the pi cancels out with the pi, and I'm just left with 2 meters squared per minute as my answer. Number 26 is a piecewise function definition for f. So when they're asking you the antiderivative from negative 2 to 1, I have to split it up because I have one definition from negative 2 to 0, and then I have another definition from 0 to 1. So that's why I split it up between negative 2 and 0, and then 0 to 1. So I have x times f of x. What is f of x between negative 2 and 0? Between negative 2 and 0, my f of x is x, so that's why I put in that x there. Between 0 and 1, what is my f of x? It is x plus 1, so I do x times x plus 1. So again, this is x times my f of x was x times my f of x was x plus 1, because my piecewise definition changed which function I used. Number 27, average value, remember, is 1 over b minus a, integral from a to b, f of x dx. And so when I want to take the antiderivative of cosine of 1/2 x, I do need a u subs. So I have 1 over b minus a, so that's 1/4. Integral from, I went right to a u sub. I guess I didn't write the whole problem out here. So that's why I changed the bounds, because it was originally negative 4, and then 1/2 of negative 4 is negative 2. I went right to u's here. 1/2 of 0 is just 0. And then I have cosine of u times, my du is 1/2 dx, so I needed 2 du, so I put that in. Now, you can go ahead and solve that. You know the antiderivative of cosine is sine. So you would do sine of 0 minus the sine of negative 2. Now, that's not an answer choice, that's here. So the problem is the sine of 0, well, we know the sine of 0 is 0, because, again, this is the point 1, 0. Sine is a y-coordinate, so it is 0. But what is the sine of negative 2? The sine of negative 2 is not in any of my answer choices. You have to remember that the sine function is an odd function. It's odd because, remember, it looks like this. And so, since it's odd, you know the sine of negative x is negative sine of x. It's the opposite. So sine of negative 2 is going to be the opposite of the sine of 2. And so a negative sine 2 is just sine 2. And then we have the 1/2 because we're taking the average value. So that's the answer to that problem. Number 28 is a really neat one, a really cool one. I really, really like this problem. U is 2x to the 1/2. I rewrite it so that I don't forget a chain rule. So du would be 1/2 dx to the negative 1/2 times 2, because I needed to chain, times 2 dx. So let's break that down. I cross out this 2 with that 2, and I have a 1 over root 2x dx. So scoot that over there, and I get root 2x du equals x. I don't like this because remember, you can never mix and match the x's and the u's. I need to get it all in u's. But I note that this root 2x was the definition of my u. So I can replace this with a u, and now I'm happy because this is u du. Go back to the original problem. Change to u bounds, need all u's. So root 2 times 2, root 4 is 2. Root 8 times 2, root 16 is 4. Then instead of my dx, I now have a u du. So replace that with a u du. And then I have u plus 1 on the bottom. That's my answer to that one. Okay, now we're in the calculator section. So I want to go over number 30. So this one is saying that f be the tangent of x, let g be x squared. Where do they have parallel tangent lines? Parallel tangent lines, parallel means same slope, right? So let's find the slope. Tangent x, the derivative of tangent x is secant squared. The derivative of x squared is 2x. Again, make sure you know the derivative of tan x is secant squared. Fair game from now on, okay? So then I want to know where they are the same, right? Parallel is same slope. So in Y1, you don't have a secant button on your calculator. So what you need to do is you need to do 1 over cosine. And that cosine is squared because it's 1 over cosine squared. You need to put the parentheses in this order. You need to put the parentheses around the cosine. So make sure you know how to put this in your calculator because that's the last thing you would want to do is not be able to enter it in your calculator correctly, right? So make sure you practice this. Put that in Y1, put that in Y2, and you want to know when it's the same. So find the intersection point, and you should get the answer. I think it was C. On this next one, they're asking you, where does f prime equal the average rate of change? You need to know average rate of change is just the slope. So find the slope. The slope is, in this case, between a and b, f of b minus f of a all over b minus a. What is f of b? That's just 1 over b. What is f of a? That's just 1 over a. So 1 over b minus 1 over a all over b minus a. Get a common denominator. That's ab. So how do I get from b to ba? I have to multiply by a. So multiply by a on the top. How do I get from an a to a ba? I have to multiply by b. So multiply by b on the top. So I have a minus b on the top over ba all over b minus a. It's a division problem, so I have this whole thing divided by this. So I'm going to change it into multiplication. This whole thing times the reciprocal of this, right? So I have 1 over b minus a. Now, b minus a could be rewritten as negative a plus b. In other words, negative parenthesis a minus b. Why did I rewrite it like that? So that I can cross out the a minus b with this a minus b, and I'm left with negative 1. So I get negative 1 over ab to simplify that. Now, I need to set that equal to f prime. What is f prime? Well, I have 1 over t. So I would think of that as t to the negative 1. So the derivative of t to the negative 1 is negative t to the negative 2, which is negative 1 over t squared. Now, set this equal to that. So negative 1 over t squared equals negative 1 over ab. So the tops are the same. The tops are both negative 1. So set the bottoms equal. T squared equals ab. Take the square root, and I get t equals plus or minus root ab. Since it's positive values, I just have the positive root, and that's about it for that problem. On this next problem, it says that f is positive, increasing, and concave upwards. So draw the picture, and then they want to know, is the left bigger, is the right bigger, is the trapezoid bigger, or is the actual bigger? So obviously the curve is our actual, right? And then the left would obviously be a major under approximation. The right, just draw one rectangle in. The right would be a major over approximation, right? And then the trapezoid is still an over approximation. So we know that it's left, actual, trapezoid, then the right. And again, all I did was I drew the picture out. It was increasing and concave upward, and then I just drew one rectangle of each type, and I was able to figure out my answer. Which one do I want to do next? Let's go ahead and do number 36. So this gives you the area of the region enclosed by these two graphs. So you should put both of them in your calculator. So I put this in Y1, I put this in Y2. And the next thing I did was I needed my intersection points. So I found the left intersection point. I did second calc, found the left intersection point. Then I went back to my home screen. I stored that left intersection point, X, store in A. You need to store it immediately because that X value is going to change when you do any computations. So as soon as you find the left intersection point, store it in A. Then go back to your graph and find the right intersection point. go back to your home screen, press X, store in B, and you'll get the right intersection point at that time. Once you find the left and right intersection point, and honestly, in this question, it was a matter of symmetry. If you were able to figure that out, good for you. If you weren't, then just go procedurally, store the left one in A, store the right one in B, and then you would do fn int. In this case, because I put this in y1 and this in y2, this was the top curve, so I had to do y2 minus y1. If you have an old calculator, you would have done y2 minus y1, comma x, comma a, comma b. If you have a newer calculator, you would just write it out with an integral a to b, y2 minus y1 dx. So just make sure you're doing that all in fn int on your calculator. Okay, number 37. I've done a ton of this type recently, and as you can see, they're very popular in the AP exam. So if the velocity at t equals 0 is 4, so we know v of 0 is 4, they want you to find v of 8 in this case, and they're giving you stuff about acceleration. Well, we know that the antiderivative of acceleration brings us back to velocity. Now, how do I know the bounds? I know the bounds by what's given and what we're trying to find. So what's given is 0, what we're trying to find is 8, so I let that be my bound, so I get v of 8 minus v of 0, because again, the antiderivative of a is v. We know that v of 0 is 4, so we know that v of 8 is going to be 4 plus this antiderivative, so 4 plus the antiderivative, and we find the antiderivative, we have to do a left Riemann sum approximation, because they tell us to do that in this problem. And yeah, that's how you find that problem. This problem I hope you know how to do. Since it's an even function, remember that that means that everything is reflected over the x-axis. So the integral from 0 to 1 would be equal to the integral from -1 to 0. So that's the trick to solving this problem right here. This problem, they're asking you to find the average value over the interval 0 to 12. So again, that's 1 over 12, integral from 0 to 12 of f of x dx. Don't forget that the antiderivative of f of x dx, so this whole integral thing, this whole entire thing, is just saying to find the area under the curve, and we just add up a rectangle plus 1/4 of a circle to figure that out. I don't take any antiderivative in this case, because remember, this whole statement is saying what is the area under this curve, okay? So no taking an antiderivative. Simply add up the rectangle and 1/4 of the circle. In this problem, look, this is the same type of problem. It says that g is an antiderivative of f. So if you take the antiderivative of f, you get g. Okay, the antiderivative of f is g, and I use the given and what I'm trying to find as my bounds. So the antiderivative from 1 to 5, the antiderivative of f is g, so I get g of 5 minus g of 1. We know g of 5 is 7, so this is 7 minus g of 1, so g of 1 is going to be 7 minus whatever I get when I use fn int on my calculator. So I do fn int and I put this in y1. Last problem here is actually that same type of problem. So here's f prime, right? And they tell you f of 2 equals 10, and they want to know when is a maximum. So since this is f prime, remember we have a maximum when f prime changes from positive to negative. So we know our maximum is going to be at 6. So our goal is to find f of 6. So we're given f of 2. We want to find f of 6. So I use that as my bounds of integration. The integral from 2 to 6 of f prime is f of 6 minus f of 2. So f of 6 is going to be f of 2 plus the integral, right? And we know f of 2 is 10. And then the integral is just count up the boxes underneath. Just notice that each of these boxes is 5. So I counted up 1, 2, 3, 4, about 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, maybe 15, 16, 17, 18, 19, about 20 boxes. So I did 20 times 5 is 100, and 100 plus 10 is 110. So I got that answer there. And that's it for this video.